We're doing 3.4, and with 3.4, this, by the way, is page 83 of your student journal. Okay, in 3.4, we're doing proofs with perpendicular lines. All right, and there's some different theorems that I want you to kind of take a look at on on page 83 there. Theorem 310, linear pair perpendicular theorem, 311, and then if you turn the page, there's one more at the top of page 84. So I want you to read through those, just kind of make any notes to yourself about those to clarify and write down any questions you have, and then we'll go through those here in a minute. Okay, so page 83 and the top of 80. All right, so linear pair perpendicular theorem. Two lines intersect, form a linear pair. Remember, a linear pair is a straight line, add up to 180 degrees. Then the lines are perpendicular. Then the lines that intersect to form that linear pair are perpendicular, meaning that G is perpendicular to H, which also means angle 1 is congruent to angle 2 there. Okay? Because they're congruent angles, they both equal 90. And 3.11, perpendicular transversal theorem. Okay? If a perpendicular line, or if a line is perpendicular to one of two parallel lines, then it has to be perpendicular to both parallel lines. All right, and then the last one, 312, kind of goes along with theorem 311. Lines perpendicular to a transversal theorem in a plane. If two lines are perpendicular to the same line, then they're parallel. So since M and N are perpendicular to P, these two lines have to be parallel. Okay, and we've kind of referenced some of that this year, but now we have a theorem for it. All right, any questions there? Okay, here's what I want to do. I want you to take a look at this problem. Okay, you also fill out the top of your note page if you want. Our info there, the page number. Take a look at it, maybe talk about it with your groups, how you actually could go about solving that. Come up with a plan of attack. Okay, thoughts? What can we do? What's the shortest distance between 2 points? A straight line. Okay, so from A to line, this line right here, line BD, the shortest distance would be this straight line? Or this straight line? Or that straight line? So when we actually use that statement, we say, hey, the shortest distance between 2 points is a straight line. Well, there are three straight lines that connect point A to BD. Okay, so we can't actually say it's a straight line. We have to be a little more specific about it. What type of straight line? No one's willing to. Three of you are willing to give it a shot. Mickey, what do you say? Straight line that intersects it at a right angle. It's perpendicular. Good. Okay, the shortest distance between 2 points is a straight line that intersects that line at a right angle. Therefore, we want to find that distance. Now, how can we find the distance from here to here? Oh, dude, no one remembers? Yeah? Okay, you should go with it. It is called the distance formula. Remind your neighbor what the distance formula is. Okay, what's it start with other than D? I gave you the hard part here. D equals. Yes, sir. Hunter, go. It is related to the Pythagorean theorem. So Pythagorean theorem, if you remember, is a squared plus b squared equals c squared. So it's related to the Pythagorean theorem. We are squaring two sets of things that we're adding together. That would be kind of our A and our B. Yeah. Dealing with coordinates. So in Pythagorean theorem, we're dealing with a picture which we could actually apply here. But when you're just given coordinates, which you may be today, the coordinate there and that coordinate there. Yeah? X's go here, Y's go here. A couple of you think they got it, Jordan? X minus X. X 2 minus x1 and y2 minus y1. This is your second x value minus your first x value, which it's up to you which one you call your first and second. So if I call this my first and this my second, that means this has to be my first y value and this has to be my second y value. Okay? Now, what am I missing? Yes, Brennan? I have to square root it, right? Because there's no squared over here. The Pythagorean theorem, if we kind of move this around, says a squared plus b squared equals c squared, which we have our a squared, we have our b squared. This would be kind of our c squared, but you could get rid of that square by taking the square root of both sides. And that's what you do with the distance formula. Okay? There we've got it. So, go ahead and find the distance there. x2. I put up my work, but I don't think I used the same x1, x2. Oh, I did. Well, hey, man. I just put this up. Ka-chow. That's what I've got. Notice this makes a double negative, which makes a positive. And when I do that, I get 4 squared plus negative 4 squared, which is 16 plus 16, which is root 32, which is 4 root 2. When you simplify it. I'm waiting. This is I know that's a messy 4, but I was using a pen last night. I didn't have pencil. All right, 4 root 2. What is that approximately? What's root 2 approximately? Okay, what's root 4 approximately? 2. What's root 1 approximately? 1. Okay, they're actually exactly 1 and 2. All right? So, between root 1 and root 4, you get root 2, which is in between 1 and 2. It's probably closer to 1. Stay with me here. So it's closer to 1. 4 times 1 is 4. So now when you put it in your calculator, your answer should be around 4. Probably a little more than 4. It's like 4.8-ish, 5.2-ish, 5.6-ish. Okay, right around there. All right. Kind of. We know it's in between 4 times 1 and 4 times 2. 4 times 1 is 4. 4 times 2 is 8. In between 1 and 8. Or, excuse me, 2 and 8, or 4 and 8. All right. That's all right. So it's approximately 5 point, what'd you get, Alexis? 5.6. All right. Very good. We're good? All right. Looks like you guys are amazingly ready to move on. So I want you to go back to your student journal. Page 84 of your student journal, please. On page 84, I want you to complete problems 1 through 4. We'll go through those here in a minute. Actually, a little longer than a minute. Hey, I'm going to put up the answers for the first 2. There, you guys can see how you did. So number 1 and 2. Check your work out. Now, you may have titled your points differently. Doesn't matter which one you call x1 or x2. I decided to call this one x1, and this one y1, and this one x2 and y2, but it doesn't matter. It's up to you. And the same thing on this one. I went with -3, -4. My a term is my x1, y1, and x2, y2. Notice you're looking for where it hits that right angle, or where it has the right angle, where your line hits it. How many got them? Question, Danica. If it has a slope of 1 and -1, you can do what? A root 2. You're thinking of a right triangle. It depends on what type of right triangle it is. Okay. So maybe I'll come over and you can kind of show me where. Did you use it on one of these? Yeah. Which one did you use it on? I used it on one answer. Okay. So I'll come over and I'll check out what you're doing. Yeah, Alex?
So do you have to have the 2 square root 2?
You mean you just put the decimal?
No. Oh, you just put the decimal?
No, I'd prefer you put root 8 and then simplify to 2 root 2. And then if you want to round it after that, you can. You don't know how to simplify from here to here? Okay, you guys, simplifying radicals, I'm just assuming that everyone knows how to do that because as an algebra skill. Okay, root 8, you got to say what perfect square goes into it. So the perfect square is other than 1. So what's the first perfect square other than 1? Okay, 1 times 1 is 1. 2 times 2 is 4. So does 4 go into this? Yeah. So this can be broken down to root 4 times root. 4 times what's 8? 2. So root 4 is what? 2. And root 2 can't be broken down. So that simplifies to root 2. Yep. All right. Yeah. Yeah, you should always simplify. Simplify your radicals. Totally radical, man. Okay? All right. Hey, the next two. You guys done with them?
No.
How many are done with the next two? Who's not done with the next two? All right, give you another minute or so there. See how we did? Dun, 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 dun. Woohoo! All right, make sure you're asking as I'm cruising around if you got questions. Hey, some very good questions. Any other questions? Jordan. Correct. In order to use the line, it has to be a right angle. It has to intersect at a right angle. So we're dealing with this line here and that line there. Okay? All right. Abdul, how you doing? Good. Just making sure. Wouldn't want you to be doing bad. All right? Here we go. 5 through 8. Next page, please. Page 685, your student journal. I want you to complete those. Determine which lines, if any, must be parallel, and explain thy reasoning. I realize you may not be done with all of them, but let's at least go through the first ones. Number 5, parallel?
Mm-hmm.
I'm going to say none of them are parallel because perpendicular lines do not prove parallel lines. In order for us to show that they're parallel, as one of my students said just a minute ago, you'd have to have a right angle marking there as well.
What about the perpendicular transversal theorem?
Well, perpendicular transversal theorem, what's that theorem say? Perpendicular transversal theorem, I carry it around with me everywhere I go, says in a plane, if a transversal is perpendicular to one or two, to one of two parallel lines, then it's perpendicular to the other. So it says if it's perpendicular to one of two parallel lines. Now,
They're not marked parallel.
we don't know they're parallel. We're trying to prove they're parallel. Therefore, in order to do that, we would have to use that other theorem, which is the lines perpendicular to a transversal, which says in a plane, if two lines are perpendicular to the same line, then those lines are parallel. So we'd have to see the other right angle marking. Very good. I heard some good arguments there going on. How about the next one? Number 6. Yes? Yes, P is parallel to Q because all right angles are congruent, and then you have corresponding angles. Okay? Since you have these two right angles, you could actually use the lines perpendicular to a transversal theorem as well. Yes?
Can you just state the theorem instead of saying?
You cannot say theorem 3.12. You'd have to say lines perpendicular to transversal theorem, or you could use alternate or all right angles are congruent and then corresponding angles. That would be fine. Yeah. Okay? Number 7, what do you think? Who says yes? You can prove 2. Okay, which 2? Come on, someone be brave. Maddie? Are you getting it from your secret agents? No? Oh, JK? Are you serious about that? Or are you JK? You serious? Not JK. Okay. So you're saying J is parallel to K. J is parallel to K, yes. Supplementary angles and corresponding angles. So you could use because if we've got here and here, we know that these angles right here, if this is a right angle, this has to be a right angle, and then you'd have corresponding angles. Okay. What else could we say? Drew? Okay, M is parallel to M because of alternate interior angles and supplementary angles. So alternate interior, and then those are supplementary. That would work as well. Good job. Assuming all right angles are congruent on them, right? Okay. No JKing about it. Right, Maddie? All right. Okay, number 8, what do you think? Yes? Can we prove M to N? What do you think, Jeremiah? No? Okay. I would say M to M because of congruent supplementary angles. Since these are congruent and they're supplementary, that makes each of them a right angle. And if that's the case, I then have alternate exterior angles. The markings show that they're congruent. One arc and one arc, yeah. So yeah, that's a good point. What's that? They don't have to be the same size arc, no. All right. If it was the same size arc, it'd look like a rainbow. Don't want that. Without color. So, and then how about S is congruent to T or parallel to T because of, so you'd have to look at S and T and look at the line that connects them. This transversal connects them. So I always think when I'm trying to prove lines parallel, take the transversal that connects them. So we have here or here. There's not much going on here, but over here you have right angle and right angle. Therefore, you have corresponding angles. Okay. Questions? Right. Neato burrito, man.